In this problem, I need to evaluate without using a calculator this expression here, the tangent of the arcsine of negative 12/13. Well, if I can't use a calculator, the first thing that comes to mind is the unit circle, but negative 12/13 definitely doesn't lie on the unit circle. So it most probably means I'm going to have to sit and draw a picture and figure out something more about this angle. So let's rewrite this problem. This looks way too complicated. So remember, inverse trig function means the same as find an angle. So I'm going to write this as find the tangent of theta where theta is equal to the arcsine or inverse sine of negative 12/13. So I've broken it down into two parts. I'm going to find the tangent of theta where this is what theta means. So remember, whenever we have an inverse trig function, let's rewrite what this statement means. This means that the sine of theta is negative 12/13. And remember, every inverse trig function has restrictions on it, and this says that theta has to lie between negative pi over 2 and pi over 2. So what I'm restricted to is, if I want to think about this, is that I can have an angle in quadrant 4 down here as long as I rotate negatively, or I'm going to be in quadrant 1 when I rotate in a positive direction, because my angle, my answer for that part of the problem has to lie between negative pi over 2 and pi over 2. So let's think about it. The sine of theta is a negative number. Can I be in quadrant 1? No, because all trig functions are positive in quadrant 1. Therefore, I have to be in quadrant 4. Let's check. Is the sine negative in quadrant 4? Yes, the only two trig functions that are positive in quadrant 4 are the cosine and its reciprocal. So I need to draw an angle in quadrant 4, and excuse my terrible drawing here. So I need an angle down here in quadrant 4. Here's my angle theta. And I know that the sine of theta is equal to, so the sine of theta is equal to negative 12 over 13. And remember, what's the definition of the sine of theta in terms of x, y, and r? It's equal to y over r. So remember, r is always positive. R is going to have to equal 13. And y is going to have to equal the negative 12. Well, if I look on my picture, y is equal to negative 12, and r is equal to 13. I need to find x. How are we going to find the x coordinate? Well, x squared plus y squared equals r squared. And so x squared plus negative 12 squared equals r squared. R is 13, 13 squared. X squared plus negative 12 squared is positive 144. 13 squared is 169. Let's subtract 144 from both sides. So I get x squared equals 25. So x equals plus or minus the square root of 25, which is plus or minus 5. But since I'm in quadrant 1, I'm in quadrant 4, not in quadrant 1. Believe it or not, that set of 4. X has to equal positive 5. So I now know my x coordinate is equal to positive 5. So now let's go over here, and remember I need to find the tan of theta. The tangent of theta in terms of x, y, and r is y over x. Well, we're given y is negative 12. We just found x was positive 5. So what is the tangent of theta? Negative 12/5. So this expression that I was asked to find up here is equal to negative 12/5. So that is my answer for this expression.